Welcome. In this video, we are going to take a look at problem 36. It is from chapter 3 of College Physics 2E by OpenStax. In this problem, we have the world long jump record, and that was set by Mike Powell of the US in 1991. And so now treated as a projectile, we need to find the maximum range a person can have if they have a takeoff speed of 9.5 meters per second. And we need to state our assumptions. All right, let's start with what we know. We know the initial velocity, the takeoff speed, is 9.5 meters per second. We are looking for the maximum range, and now we will state our assumptions. Okay, so for maximum range, we will need theta naught to be 45 degrees, and that is because we will be taking the sine of 2 times theta naught. And so that will be the sine of 2 times 45, so sine 90, and that is 1. So that is the maximum range we can get, is when the sine of the 2 times the angle is 1. All right, we will also assume that, that the ground is level, so that the starting and ending heights are going to be the same. All right, and so now we can find the range. We will use V naught squared times the sine of 2 theta naught divided by G. Okay, our V naught is 9.5 meters per second. We square that. Sine of 2 times 45 degrees, all divided by 9.8 meters per second squared. This gives a range of 9.21 meters. So Powell was either going a little slower or he didn't have the optimal angle, but he was close. So the maximum range, if you are taking off at 9.5 meters per second, is going to be 9.21 meters. I hope that was helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.